Good afternoon. During the last class, we discussed about the topic, is the matter around us pure? In that section, we learned that everything in the universe is made up of either matter or energy. That means I and you, the earth, the planets, the sea, the air, and everything. Everything in the universe is classified into what are they? They are matter and energy. Why energy? In sun, it is inside sun, their energy is stored. Then we have come to the discussion about what is matter. The matter we have already learned that matter is something that occupies space and volume. Then came the question, there is anything that is not matter. Okay, we also give example to it. What is example? Shadow. That is not a matter. It does not has mass and it does not need space to occupy it. Then matter is again classified into pure substance and mixtures. Pure substance and mixtures. We learned that pure substance are those which has only a same kind of particles. Mixtures, on the other hand, they have different types of particles. Pure substance can be again classified into elements and compounds. Pure substances are again classified into elements and compounds. Elements contain only one type of particles. For example, hydrogen, oxygen, nitrogen, iron, aluminum, etc. elements that contain only one type of particles. At the same time, compounds, water, it contains more than one type of particles. For example, water, it contains hydrogen and oxygen. Similarly, carbon dioxide, carbonic acid, etc. are compounds. Similarly, mixtures can be again classified. Mixture. The word itself says that it contains more than two kinds of particles. More than two kinds of particles. They may be again classified into homogeneous and heterogeneous. Homo means same. Homogeneous and heterogeneous. Homo means same. That in a homogeneous mixture, every part of has the same property. Every part of the mixture has same property. For example, sugar solution, salt solution, etc. homogeneous solution. In sugar solution, we know that sugar particles and water particles. Similarly, in a salt solution, there are sodium chloride particles and water particles. Even though there are two kinds of particles, they are evenly distributed and they are the quality, it shows the same property throughout it. Then in the heterogeneous mixtures shows different property in the different parts. Example, soil. Soil dissolved in water. There are sand particles, mud particles, and other impurities, water, etc. They are not same throughout the solution. They are heterogeneous. Milk is a heterogeneous. Though it seems to be, we can study about milk again, seems to be homogeneous, it is actually not homogeneous. In milk, there is fat particles, protein particles, and at the same time water particles. They are not, in look, it seems to be homogeneous, it is actually not homogeneous. Then came to another question where in different answers are given. In some tests, air is described as a homogeneous mixture, In other some references, it is said to be a heterogeneous mixture. But actually, it depends upon our textbook. That means pure air is a homogeneous mixture. Pure air is a homogeneous mixture. But almost our air is not pure. It contains dust particles and other impurities. If the dust particles avoid impurities and dust particles, that means polluted particles, air is considered as a homogeneous mixture. And at the same time, on the other hand, it is a heterogeneous mixture. Today, we have to discuss about solutions. Solutions. What solution? In every day, more than 5 times we using different types of solution. Can you give an example of a solution? In every day before the meals we add salt, table salt or common salt to our food to increase the taste. Sodium chloride, salt is a sodium chloride is a solution. Sodium chloride dissolved in water. Common salt dissolved in water. It's a solution. Then what's the solution? It's a mixture of 2 or more substances. It's a homogeneous mixture of 2 or more substances. It's a homogeneous mixture of 2 or more substances. That is homogeneous. Homogeneous means homogeneity in the particle level. Homogeneity. Homo means same. If we take a glass of salt water, or if we take a glass of lemon juice, lemonade means lemon water. Malayalam says naringa lemonade. It contains, we all know that, what are they? Lemon juice, water and sugar. It's also a homogeneous solution. A homogeneity in the particle, identical in the particle. Its particles are evenly distributed. That if we take a glass of salt in every corner, it shows the same property. Identical, the particles are evenly distributed. What's evenly distributed? Same distribution. Particles are same in every part of the solution. That is going to be solution. It is a homogeneous mixture of 2 or more substances. In our common use, upon hearing the word solution, we think that the solution is the liquid form only. No, it is not correct. Solution, now day to day they came to contact with not only the liquid solution. By knowingly or unknowingly, we came to contact with other solutions. What are they? There are liquid solutions, solid solutions, and gaseous solutions. Can you give an example? We always say that salt dissolved in, common salt dissolved in water. It's a solid liquid solution or liquid solution. Then there may be solid solution also. What are the solid solution means the 2 constituents or 2 components. We have seen that homogeneous mixture of 2 or more substances. Solution. One substance cannot form a solution. Water alone cannot form a solution. It's only one part of a solution. Similarly, common salt alone cannot form a solution. Common salt is a compound. When common salt dissolved in water, we say it is salt solution. Sugar is a compound. It's not a solution. Water is a compound. When sugar dissolved in water, we say sugar solution. So, in a solution, there may be at least 2 or more substance. That means sugar and water, glucose and water, common salt and water. That they are the liquid solution. What are they are classified into solid solution, liquid solution, then solid solution. Can you get some solid solution? Alloys. What are alloys? Alloys are mixtures of metals. I said to you that we have already the scientific world have already discovered 118 elements. 118 elements. Out of 118 elements, nearly 90 elements were metals. The remaining below 30 elements are either metalloids or non-metals. For metals, elements are generally classified into metals, non-metals and metalloids. Metals, non-metals and metalloids. There is a third thing, metalloids. Metalloids means the elements which shows both the properties of metals and non-metals. Because we came to the different kind of solution. One solid solution, liquid solution. Liquid solution means sodium chloride solution, sugar solution, etc. Liquid solution. Then solid solution. Solid solution means mixtures of two metals. One of them is must compulsory a metal. Can you see the example of an alloy? Steel is a common alloy in which what are the components? Consists of steel, iron and carbon. Iron is a metal, the carbon is a non-metal. We know that in our kitchen almost all the vessels, plates, now we are using steel. It is not iron. If it is purely iron, it undergo rust very easily. So if iron is mixed with a certain amount of carbon, it becomes an alloy. It is a solid solution. Similarly, brass. Do you know where brass? Brass, Malayalam it is known as pichava. Then similarly, bronze. They are also alloys of metals. In brass, they are a mixture of copper and zinc. 70% copper and 30% zinc. These two metals are chemically combined in the form to form a solution, solid solution. But what their properties? They cannot be, the constant elements, the component elements cannot be physically separated. Though they cannot be physically separated, they show their individual properties also. They cannot be separated. By what's the merit of the alloy? By improving the quality of the metal. By improving the quality of the metal. That's how now I said to you that what is if the metal iron only, iron means Fe, it undergo rust very easily. At the same time, steel does not undergo rust. It does not form rust on its surface very easily. So, you can improve the quality of by making alloy. It's a solid solution. Then there is also gaseous solution. What's in a gaseous solution? In the gaseous state, that is air. Gaseous solution air. We all know that 71% nitrogen, 78% nitrogen, 20% oxygen, and the other remaining hydrogen, inert gas, carbon dioxide, and other including 2%. So similar 100%. So air is a gaseous solution. So it can be there may be a number of solutions: solid solution, solid liquid solution, gaseous liquid solution. We can detail study in this chapter. Solid liquid solution, solid solution. Now I said here by on hearing solution, the thing came to your mind is solution is only in the liquid form. It is not correct. Solution is obtained in the either in the solution form or in the liquid form or in the gaseous form. There are three states of matter. So solutions can be produced or obtained in the three different states also. For example, liquid solution, example sodium chloride and water, solution. So example of solid solution is alloys. Example of alloy is one brass. Brass is a mixture of two metals, copper and zinc. Copper 70%, zinc 30%. These two metals combine to form an alloy. There's only one condition. When alloy is formed, one of them is at least metal. There may be two or more compounds maybe, but at least one of them may be metal. For example, so many items in our day-to-day life where they are made of alloys. The other example is bronze. You heard about bronze medal, gold medal, silver medal, bronze medal. And bronze means copper and tin. Bronze is made of copper and tin. The metal copper and tin. That's an alloy, sold alloy. Then we came to this, I already said to you that steel knife, steel plate, steel vessel. What are the components of the steel? The main component is iron. The amount of iron is almost 97%. Below 3% there is carbon. The blade we use for shaving is it is written as stainless steel. Stainless steel. That means it does not undergo. It is resistant to air and water. It does not rust easily. That is stainless. Stainless. Almost every steel items it may be written as stainless. That means it does not. It is undergo rust very easily. It prevents the reaction between oxygen and water, etc. So the gaseous solution. Gaseous example is pure air. Pure air means pure has importance here. That is air is free from dust particles and other polluted gases. Then we came to the second solute, solvent, solution and solubility. You are just familiar with these terms: solute, solvent, solution and solubility. In your day-to-day life, you have prepared a common salt solution. This is common salt or sodium chloride. This sodium chloride is taken in a beaker. Then add some water. sodium chloride is taken in the beaker, add some water. Here, the substance dissolved is called a solute. Substance dissolved. What is solvent? Water is the solvent. Which substance dissolves solute? Here it is dissolved. Dissolved. Here it is dissolves. Here water is the solvent. What is solvent? Then where salt is dissolved in water, we get salt solution. Solution means solute plus solvent. Solute plus solvent, that is called a solution. So, in every solution, we can find three things. What are they? Here, what are they? This is solute. The other thing we have seen, what is the other water is solvent. Then solute and solvent mixed together, we get a solution. Then there came the next term, solubility. At a given temperature, the solution can't or the solvent can't dissolve the maximum amount of solute. The amount of solute dissolved, the amount of maximum salt dissolved at a given solution at a given temperature is known as solubility. That means, considering, we have seen that considering the salt completely dissolves. It completely dissolves. Then we add more than, again we add solute to this and again dissolves. That solute also dissolved at a given temperature. These are the wells, and that's because that the old some solute particles remain there. Once they are doing well, after some time, all the solute particles are dissolved. Now, the amount of solute dissolved in solvent at the given the maximum amount of solute dissolved in the solvent at a given temperature is known as solubility. Solubility. If you add more than salt, it remains undissolved. Its capacity is over. This amount of water, it includes 150 ml of water. We have taken 150 ml of water. It can dissolve the maximum amount of salt in it. So, the amount of solute dissolved in it is known as its solubility at this temperature. This temperature means at this room temperature, the given temperature. Then there comes the solutions are again classified into three. Now, in this section, there comes a number of terms. All the terms you must be familiar with it. One is solution, solute, solvent, solution, and solubility. There comes another term, saturated solution, then there is a super unsaturated solution. Solutions can be again classified. We have learned that how we can prepare a solution by dissolving solute in a solvent. By dissolving solute in a solvent, we can prepare solution. This solution can be classified into three. What are they? Unsaturated solution, saturated solution, and supersaturated solution. We can see what are they. In this beaker, we have dissolved the maximum amount of salt in it. If we add more salt, it remains undissolved. It is dissolved. Maximum amount of dissolved. The amount of solute that can be dissolved in the solvent is maximum. No more salt can be dissolved in it at the given temperature. This is a saturated solution. That means what is in saturated solution? The amount of solute that can be dissolved is dissolved in it in this given temperature. Then if we add more solute in it, it cannot be dissolved. It remains unsoluble. So this is saturated, maximum dissolved in it. Then if we add more solute to it, what will happen? It remains undissolved. Then how we can dissolve it? If we heat the saturated solution to 5, now it is 30 degrees in the atmosphere temperature. If we heat the solution to 5 degrees more, then on heating we know that the remaining solution can be dissolved. That is supersaturated solution. That means what's a supersaturated solution? The solution can dissolve more solute than it can. How we dissolve more solute in it? By increasing the temperature. By increasing the temperature of the solution, we can dissolve more solutes in it. That's not the given temperature. If the maximum solute is dissolved at the given temperature, it is saturated solution. If we increase temperature to 10 degrees more, then we can dissolve more solute. That is supersaturated solution. Then what is unsaturated solution? We take only 1 spoon of common salt and add water to it. We can easily dissolve. It is unsaturated. What does it mean? It does not contain the minimum amount of solute. It contains the least amount of solute, only 1 spoon. At the same time, here we dissolved 3 spoons. So it is unsaturated. It contains only little amount of solute. The maximum amount of solute does not dissolve in it. That is unsaturated solution. So what are they? Our scale is what? Saturated solution. Our scale is saturated solution. What saturated solution? The amount of solute that can be dissolved at the given temperature can dissolve in it. That is the saturated solution. If we increase the temperature, what happens? We can dissolve more solute in it. That is supersaturated solution. If the minimum amount of solute does not dissolve in it, it is unsaturated solution. Then we can see what happens when it remains for a long time. When it remains for a long time, unsaturated solution does not change. Saturated solution does not change. But supersaturated solution, what happens? We know that how we made supersaturated solution by increasing the temperature. On heating, the temperature increases and it can dissolve more solute in it. Then what we can do? If we remain the solution for some time, what happens? If we remain solution for some time, the temperature decreases and the excess amount of solute dissolved is settled at the bottom. That means solution will be stable only at the saturated level. If supersaturated, we make a supersaturated solution by increasing the temperature, it is not stable. Or when the temperature decreases, the excess solute dissolved is settled at the bottom. We can see it at the level. So, this is the three kinds of solutions. What are they? Unsaturated solution, saturated solution, and supersaturated solution. Then there may be again there may be different solutions. Concentrational solution, concentrated solution, dilute solution, and concentration solution. We can be studied in the next class. Today, what we discuss about? We discuss about solutions. What are the solutions? I already said that it is a homogeneous mixture of what means homogeneous mixture of two or more substances. Homogeneous mixture means at the particle level, there are same the quality, the property same throughout it. If we prepare the sodium chloride solution, on the top and the bottom there are the taste of salt. That is evenly, particles are evenly homogeneity in every corner, in every part. That is homogeneous solution, homogeneous mixture of two or more solution. There are different types of solution. You may be familiar with not only the liquid solution, but at the same time, the liquid solution, solid solution, example alloys, then gaseous solution, example air. Then came the other sentence, solute, solvent, solution. Today itself, you prepared a sodium chloride solution. Then identify what is a solute, what is a solvent, what is solvent. Similarly, you prepared a sugar solution and identify what are they. Then you reach a definition. Similarly, the solution can be again classified into the amount of solute. Solid solution, liquid solution, gaseous solution means, that division means the physical state of the substance. But saturated solution, supersaturated solution, unsaturated solution means the amount of solute dissolved. According to the amount of solute dissolved in it, solution can be dissolved, classified into saturated, unsaturated, and supersaturated. Today, you make a list of these terms and prepare solution and identify it. We can see it the next class. Okay, thank you.